This video is on converting between moles and mass. Now to do this, we'll need to know about something called molar mass. This is the mass of 1 mole of atoms. So the mass of 1 mole of atoms is called a molar mass. And this comes about from carbon-12. So the average of all of the carbon atoms, on average, will weigh exactly 12.01 AMUs. So pick an average carbon atom, 12.01 atomic mass units. But if you have a whole mole of carbon atoms, so if you have 6.02 times 10 to the 23 carbon atoms, that will weigh exactly 12.01 grams. So the unit for an individual atom is the AMU, the atomic mass unit. The unit for having a whole mole of atoms, that's grams or grams per mole. So what's the molar mass of a mole of hydrogen atoms? Well, we find that on the periodic table. So we get out our periodic table, and our periodic table is going to tell us our atomic number at the top. So for hydrogen, that's 1, meaning it has 1 proton in its nucleus. But the atomic mass is 1.008. So 1 mole of hydrogen atoms has a mass of 1.008 grams. It means if you had a whole mole, 6.02 times 10 to the 23rd, that would be the mass. Now, if you had 1 hydrogen atom on average, the average hydrogen atom would have a mass of 1.008. There'll be different isotopes, so no single hydrogen atom will have that exact mass, but on average, if you grabbed one, it would have an average mass of 1.008 grams. What about neon? Well, neon is atomic number 10, so 10 protons in a neon atom, but its atomic mass is 20.18, so 20.18 grams. And sometimes we write grams per mole or just grams per MOL when we're talking about a molar mass. Okay, what about carbon? Well, if we had a mole of carbon, we'd have 6.022 times 10 to the 23rd atoms. What would that weight be? Well, we find it on the table. Atomic number 6 for 6 protons. And then its molar mass is 12.01 grams, right here at the bottom of its box on the periodic table. So we look at the bottom of the periodic table, and we find 12.01 grams for 1 mole of carbon. What about if we have a mole of sulfur? Again, a mole means we're going to have 6.022 times 10 to the 23rd atoms. We find sulfur. It has atomic number 16 protons in a sulfur, and the average mass of 32.07 grams if we had a whole mole of sulfur. So again, I like to write this sometimes grams per mole or grams per MOL as well, just to show that that's the grams that are in 1 mole of that substance. So what does a mole of carbon look like? Well, these are kind of mole samples of approximate, size. Here's like a watch glass like you'd find in the lab. And basically, a mole of sulfur atoms or 32 grams of sulfur fills up about a watch glass that you'd find in the, in an in-person laboratory. And so, this idea of 6.022 times 10 to the 23rd atoms, it's so many atoms. But the actual mole sample is, it's a reasonable sample size. So we use this idea of a mole because those are reasonable sample sizes for in the lab. And why do we need, this mole that has so many atoms? Well, we need it because atoms are so teeny tiny. So we have a huge number of atoms in a mole because atoms are so tiny. That a mole gives us a reasonable sample size like the ones shown here. Okay, so molar mass can be used as a conversion factor to get between moles, which we can abbreviate MOL, to get between moles and mass. Okay, so to convert between moles and mass, we're going to use molar mass, find that on the periodic table for this conversion factor. So let's tackle this first example. It says calculate the moles of aluminum in 107.8 grams of aluminum. So our known here is that we have 107.8 grams of aluminum. I'll just write AL. And I always like to put my known over 1, really just so I don't mess up and put something else there when I'm doing conversions. Now I'm going to just sort of on autopilot bring down my units, grams of aluminum. And I don't want to be in grams anymore. I want to get to moles. It says calculate the moles. So I want to be in moles of aluminum. So we need a conversion factor between moles and grams of aluminum. And I'm going to find that finding the molar mass of aluminum on the periodic table. So take a second, find aluminum on your periodic table. When you find it on your periodic table, you'll find the mass of 1 mole of aluminum, and you should get 26.98 grams on the table. So for every 1 mole of aluminum, there are 26.98 grams of aluminum. Okay, so the grams of aluminum just cancel. 107.8 times 1 is just 107.8. 26.98 times 1 is just 26.98. And we go ahead and we divide 107.8 by 26.98, and we get 3.996 moles of aluminum. So that's how we can use molar mass to convert from grams into moles. Okay, let's try another example. Let's see if I can move myself out of the way, though. We're going to calculate the moles of carbon in 0.0265 grams of pencil lead. Lead's not really lead, it's graphite or carbon, right? And so this wouldn't be the element lead. We are talking about modern graphite, and modern graphite is actually carbon. So let's go ahead and write down our known. We find our known in the problem, 0.0265 grams of, okay, we can write out carbon, I started to. We'll put it over 1. We'll bring down grams of carbon. That's the unit we don't need anymore. Put it in that basement or that denominator to get rid of it. And then it says calculate moles. So that's where I'm trying to go to in my numerator. I want to be in moles of carbon. What's my conversion factor here? It's going to be the molar mass that I find in the periodic table. So I'm going to go to my periodic table. I'm going to go to the bottom of the carbon box and find that 1 mole of carbon has a molar mass of 12.01 grams, or in every 1 mole. Remember, it'd be like 12.01 AMUs would be the average mass of a single carbon. 12.01 grams is the mass of having a whole bunch of carbons. 6.022 times 10 to the 23rd. Okay, so 1 mole, 12.01 grams of carbon. Grams of carbon cancel, and our math is 0.0265 divided by 12.01. Our units remaining are going to be moles of carbon. And when we do that math, we should get 0.00221 moles of carbon. So that's converting grams into moles. Okay, this looks interesting. It says calculate the mass of water in 0.257 moles of water. So here we're given moles and we're trying to get 2 grams. We've also got water. So we've got a compound here that we're going to have to find its molar mass for. So we need to find the molar mass for water. So we'll have to add up all of the elements present. So I like to make a little atom count. I like to go, okay, hydrogen, 2 indicates we've got 2 hydrogens, and it's really implied that we've got H2O1. Chemists are kind of lazy. Sometimes they don't write those ones. They're implied. Okay, so for hydrogen, we're going to need 2. And then for oxygen, we're going to have 1. We're going to go to our periodic table and find that hydrogen has a mass of 1.008 at the bottom of that hydrogen box. And then we're going to go to the bottom of the oxygen box and find that 16. And then we're going to add these up. So once we multiply 2 times 1.008 and then also 1 times 16, or just adding on 16 in this case. But the parentheses really help if you have, a number other than 1 there. Okay, and you should get 18.02 grams, or, grams per mole. Grams are in 1 mole of water. So that's the molar mass of water. So in other words, if we have 1 mole of water molecules, we have a mass of 18.02 grams. Okay, so we're going to write down our known. We started off with 0.257 moles of water. We're going to put it over 1. Why? Just so we don't mess up and accidentally put something else there. I know it might happen to me. Then we're going to bring down moles of water because that's what we're getting rid of. We're letting the units be the guide. And we're trying to get to mass. Well, that means to grams. We're trying to get to grams of water. Now, we just calculated that there were 18.02 grams in every 1 mole of water. Okay. Moles of water cancel out for units in our calculator then. We're going to do 0.257 times 18.02. And we're going to get 4.63 grams of water. So we can start with moles and get to grams using molar mass as well. Here we're really multiplying by molar mass when we were dividing before. Okay, we've got one more example here. Calculate the mass of sodium chloride, NaCl, in 0.257 moles of sodium chloride. Okay, so this time we're going to need the molar mass of NaCl, sodium chloride. Okay, so we are going to have 1 sodium and its mass. We go to our periodic table, we look at the bottom of the element box, 22.99, and then chlorine, 1 chlorine, 35.45. Okay. It's really helpful to have parentheses when you are adding these together, especially when you have more than 1 of each element. And when you add those up, you should get 58.44 grams, or grams per mole of NaCl. Really meaning that there are 58.44 grams in every 1 mole of sodium chloride. Okay, so let's go ahead and use this in our conversion. Our known is 0.257 moles of NaCl. We're going to put that over 1. I like to say that this is on autopilot. I don't think too much about this. I just bring these units down. Bring down the units of mole NaCl, and we want to be in grams. The question says calculate mass. Well, mass means find me G, grams of NaCl. And we just figured out that there are 58.44 grams in every 1 mole of NaCl. Cancel out moles of sodium chloride, and we're just going to multiply. In our calculators, 0.257 times 58.44 grams. And let's put our answer down here. I've got 15.0 grams of sodium chloride. Okay, so we've learned about the concept of molar mass, the number of grams that are in 1 mole of an element or a compound. We can calculate the molar mass of those two. And then we've learned how to convert grams to moles and moles to grams.